new mystery signal is repeating from a distant galaxy, and it's a weird one. The new discovery source of repeating fast radio bursts have deepened the mystery of what precisely could be producing these powerful outbursts. The source, first detected in 2019 and named FRB for fast radio bursts 190520b, seems to be frequently spitting out millisecond bursts of powerful radio waves. This has allowed astronomers to perform analysis that reveal information about where it comes from in the universe and the space around it. And those analyses suggest that there's probably more than one mechanism in the big, wide cosmos capable of producing these strange outbursts. Fast radio bursts, or FRBs, as the name suggests, are very fast bursts of radiation, lasting only milliseconds in duration that flare brightly in radio wavelengths. Most of them come from other galaxies. Only one source has been detected in the Milky Way, our galaxy, and they're extremely bright, discharging as much energy in an instant as 500 million suns. Most of these outbursts have only been detected once. They come out of nowhere, burst once, then we never see them again, and this makes them largely impossible to predict and very difficult to trace and study. But a few sources, well, 3 of them now, have been detected repeating, and they offer a tantalizing opportunity to understand what is going on, maybe. The FRB detected in the Milky Way came from a type of dead star called a magnetar, which suggests that at least some FRBs are caused by magnetar eruptions, but there are still a lot of unknowns. Are those that repeat different from those that don't repeat, says astrophysicist Kishtil Agarwal from West Virginia University. The discovery signal from FRB 190520b arrived at Earth in May of 2019, detected by the 500-meter aperture spherical radio telescope, FAST for short. It's in China, and it found in the data in November of that year. Follow-up observations of the location in the sky revealed that the source was repeating. More observations were conducted using the National Science Foundation Carl G. Jansky Very Large Array, revealing a fascinating set of characteristics. The signals were coming from the outskirts of a very old dwarf galaxy, nearly 4 billion light years away, and between radio bursts, the source seems to be beaming out weaker radio emission. This suggests that the fast radio bursts are coming from a compact, persistent radio source, the nature of which is not known. If you're a fast radio burst aficionado, this might sound familiar. That's because those characteristics are shared with another famous repeating fast radio burst, FRB 121102. This was the first FRB ever traced to a source, the outskirts of a very old dwarf galaxy 3 billion light years away, and it too is associated with a compact persistent radio source. Astronomer Casey Law of Caltech says, now we have 2 like this, and that brings us some important questions. We don't, for example, know whether one-off FRBs are repeating at energies too low for us to detect, but scientists have thought for some time that they may be at least 2 different mechanisms for producing the bursts, and discovery of FRB 190520b is consistent with this idea. And this could either mean that the different bursts either emitted by different objects or emitted by the same kind of object in different stages of its evolution. Magnetars are a type of neutron star, the collapsed ultra-dense core of a massive star after it's gone supernova and died, but they also feature an extremely powerful magnetic field. It's possible that normal neutron stars and magnetars emit FRBs in different ways. Further analysis suggests that another feature of fast radio bursts may not be as useful as measuring the universe as astronomers may have thought. This feature is called the dispersion measure, and it has to do with how light is scattered by tenuous gas in space between us and the source. High frequency waves travel more efficiently than those of lower frequency, and this can be used as a guide to measure distance. For FRB 190520b, the dispersion measure suggests that the source is 8 to 9.5 billion light years away. Independent measurements of the distance, however, show that the galaxy is not that far. Agarwal says this means that there is a lot of material near the FRB that would confuse any attempt to use it to measure the gaps between galaxies. If that's the case with others, then we can't count on using FRBs as cosmic yardsticks. On the other hand, this suggests that the persistent radio source emitting the FRBs resides in a very complex plasma environment consistent with the characteristics of a recent superluminous supernova. This suggests that whatever the source is, it formed very recently, a newborn FRB source. We further postulate that FRB 121102 and FRB 190520b represent the initial stage of an evolving FRB population, says astronomer D. Li of the National Astronomical Observation of the Chinese Academy of Sciences in China, who led the research. A coherent picture of the origin and evolution of FRBs is likely to emerge in just a few years. This has been published in Nature and originally published in Science Alert. It's on Collective Spark. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.